Hey, hi, good afternoon, everyone. Good afternoon, friends. Welcome back to our 30-day short-term training from Python to AI. Yep. So we'll quickly understand what we have covered yesterday. Then we'll jump into the topic, right? So in the previous day, in the previous session, we started with data pre-processing. What is this data pre-processing? Data pre-processing is also not called as cleansing or cleaning, wrangling, munging. So this is an important step because we are going to remove. We are going to make the data in a clean, structured manner, right? So by using this data, we are going to readily make a model. We'll build a model on top of this clean data. So that is the reason it's a very crucial step as part of CRISPR-MQ, and the end results are completely dependent on with respect to these steps, right? So as we discussed, there are in total 9 steps under data pre-processing: typecasting, handling duplicates, outlier treatment, zero and near zero variance, discretization or grouping, missing values treatment, dummy variable creation, transformations, and finally feature scaling. So in total there are 9 steps, friends. So yesterday we have covered or we have understood 2 steps. One is typecasting and the next one is handling duplicates. Perfect. What is typecasting? Typecasting is nothing but conversion of data type. If you want to convert data type from one to the other, then we have to perform typecasting. It's nothing but type conversion, right? So typecasting is it a mandatory step that we do as per data pre-processing? No. Until unless if there is any requirement, only then we go and perform typecasting. Okay. And what is the function that was used with respect to typecasting? It is as type. As type, and within the function you are supposed to pass the data type to which you want to convert your data, the type of data, right? So we have understood typecasting, and we have worked on a data set called cars. Yes, in total there are 14 columns and 430 rows or 431 rows. So it's we have imported it from offline from our offline system. It's available as an offline file. So we have imported it and started working on it. This is clear. Then we also understood handling duplicates. What is a duplicate? Duplicate is nothing but if the values present in each and every column with respect to the rows. Okay, if it is repeated with respect to the same position, then it is named as a duplicate, right? Then it is a duplicate, and we are not supposed to consider those duplicates as we move on. So, what are we doing? We are identifying using duplicated function and we are dropping these duplicates using drop underscore duplicates function. Okay, so identifying is done by duplicated function, and the dropping of the duplicates is done by drop underscore duplicates function. Duplicated function, it returns a Boolean series. Boolean series is nothing but a column in which we have or we identify only true and false as values. Okay, trues are nothing but the duplicates, and false are nothing but the rows which are not duplicates, which are not identified as duplicates. Okay, okay. Then what else did we understood? Ah, so the question is how many duplicates we have. If that is your question, we are just adding these Boolean values using some function, and when you try to add all these Boolean values, you get a number, some X number. This is representing number of duplicates, right? Okay. So under, in both duplicated and drop underscore duplicates function, there is a parameter called keep, and this keep by default takes first as the value, which means it does not mark the first record as the duplicate. Okay, whereas rest of the records will be marked as duplicate. Only the first occurrence will be marked as false, whereas the rest of the occurrences will be marked as true. So even though if you don't pass the value for keep, by default it takes first. What are the other values we have for keep? We have last and false. So last means the last occurrence will be marked as false and rest of the occurrences will be marked as true. Whereas false is nothing but all the duplicates, even including the original, all the occurrences will be marked as true. So this is not generally used because even the original one will be marked as true. Right. So this is the clear understanding, and my humble suggestion would be like start reading documentation, friends. If you read documentations of the functions, only then you'll understand the function well. You can understand the particular parameters. Okay, what does what parameters are available in the function and what values are available for each and every parameter. So everything is readily available in the documentation, right? So start going through the documentations at least from today, right? So typecasting is done and handling duplicates is also done. We have successfully dropped the duplicates. The third one is outlier treatment. Outlier treatment or handling outliers. Okay. Which plot, as part of EDA, which plot talks about outliers or which visualizes outliers? The only plot which visualizes outliers is box plot. That doesn't mean scatter plot, histogram. Yes, the secondary purpose of those plots is to talk about outliers. But in fact, we cannot tell with 100% confidence. But here, yes, if the values are less than the limits, then we can say it as outlier, and the plot is box plot, right? So what we are going to do is, if we have outliers in the data set, if there are outliers observed in the data, we are supposed to treat them. Why? because just because of these outliers, the values, the rest of the data is getting affected. This is actually making the data skewed. The original distribution of the data should be normal, and because of these outliers, you'll see a long tails. So this means it is affecting the entire data. So with respect to the data, what I'm going to do, I'm going to treat the outliers present in the data. Perfect. What are the different ways available to treat the outliers? There is a very important technique called 3 hours technique. Okay, what is this 3 hours technique? This 3 hours technique stands for R. What is this RRR? Hmm. Don't get confused. RRR is not a movie, it's a technique name. We'll discuss this. Right. Then there is one more technique called Winsorization. This is very widely used, friends, compared to RRR, while Winsorization is widely used. And we'll also discuss Winsorization, which helps us to treat the outliers. Right. So what I'll do is I'll start the show. Okay. For that, let me use the same data set. Yes. So what I'm doing is I'm importing the required packages, whatever the modules that are required for me. I'm importing all these modules. Initially, I'm importing them. Then I'll go and work on the data. Right. So I'm importing pandas as PD for data manipulation, NumPy as NP for basic mathematical calculations, matplotlib.pyplot. So this is for visualization, basic visualizations, and finally Cborn for advanced visualization. Okay, so all of these modules are imported successfully. Now let me load the data from an Excel file. Okay, the syntax is again simple, friends. PD dot read underscore Excel, a function coming from pandas which is used to read the data from an Excel file. So give the path of that Excel file within the strings quotations. Then assign a variable to this. So this will store the data which is present in that Excel sheet. The same data set. 428 rows, 14 columns. Okay, there are 428 rows and 14 columns. Done. Now, first of all, in order to treat outliers, what is mandatory? Outliers are mandatory. If you don't have outliers, what are you going to do? You'll proceed, right? But if you have outliers, you'll try to handle them, you'll treat them. So what I'm doing is I'm generating a box plot. Okay, but Akhil, when we have discussed this box plot concept in univariate plots, I think we used box plot function, right? But why are we using plot function now? Friend, that's true. Whatever the question that you have raised, it's perfect. But box plot function that I have used comes from which package, which module? This is available in PLT, matplotlib.pyplot. Am I using the same PLT? No. So that means plot is not being used. It's not from any module. Right? So am I using anything in front of plot? No. I'm using the data, df. df dot plot and within the function I'm defining all my parameters. So what kind of plot you want to visualize? Kind is equals to box. So that means you will get a box plot. Clear? You'll get a box plot. That's okay. The figure size, what should be the figure size? 12 by 18. 12 by 8. Subplots. What is this subplots? Subplots means, do you want to see all these box plots at a time in one single figure? Yes. So when I keep it as true, you will get all the box plots in one figure. Okay. Sherry. Sherry is nothing but it's a parameter which represents whether to share y-axis or not. Since I kept it as false, the y-axis of each and every box plot will be different. I'll show you. I'll show you all these things when we get the box plot. Then colors. For colors, I'm giving again a dictionary where this column, I have key value paste. So towards the left side of the column, we have keys, and towards the right side of the column, we have values. So boxes should be in blue color, whiskers should be in orange color, and one minute. Median should be in black color. Caps, I want it in red color. So I'm defining each and everything. Okay, and patch underscore artist. Do you want to fill that box with the color or not? Yes, I kept it as true, so it will be shaded. It will be filled with the color. Show flyers is equals to true. Nothing but to show outliers or not. Yes, I kept it as true, so obviously it will show me the outliers as well. So let me execute all of these lines in one single go. See, Akhil, what makes the difference between the plot that you are showing now and the plot that we have discussed in EDA? Friend, in the previous, as part of EDA, we understood the same concept. We tried to visualize box plot only. But thing is, at that stage, since we are at the beginning phase, we try to visualize box plot of one column at a time, then the next column, then the next column. Is it the same again here? No. In one figure, in one, plot itself, I'm getting subplots of all the columns present in the data. That means the difference. But you see, Akhil, the values of the plots, the y-axis values of the plots are getting, they're disturbed with the next plot. Okay, so I don't see that much clear. The subplots that are part of this plot are not that much clear. Okay, so let us do one thing. Let us add some more additional features to the plot. For that, I'm going to use a function called subplots underscore adjust. So the subplots that you have within the main plot, I'm adjusting them by keeping the width space as 0.8. So between each and every box plot, we'll have this much space. Okay, then for this entire one plot itself, I'm going to keep a title, and the title is box plot for all numeric columns. Okay, so box plot for all numeric columns will be the title, and plt.show will return as the box plot, the figure. Let me execute all of them. Now it will be clear. See, the title, and even if you see the axis, Is it getting disturbed? No. Check. Is it clear? So what do I see? I see outliers only in one column, or in all the columns do you have outliers? In how many columns do you observe outliers, friend? Obviously in all the columns. In total there are 9 columns, numeric columns, and out of these 9 numeric columns I see outliers in all the 9 numeric columns. Right? Yes. So what I do is I'll start working on, you know, treating them. So let us understand the first 3R technique. Outliers, we have it in all the 9 numeric columns, and in order to treat these outliers, we have to use some techniques. So for that, yes, in all the 9 columns, we have the outliers. So what I'm doing is, let us go and treat these outliers with 3 R's technique. This is nothing but R, R, R. What is this RRR? RRR is not a movie, it's a technique name. It's a name of the technique. The first R that you have in this technique is representing recognize. So, what does that mean? This just recognizes whether it's an outlier or not using IQR technique, interquartile range. For that, okay. But the thing is, we know that there are some components with respect to box plot. Can you quickly tell me what are the components that we have with respect to box plot? What are the components that we have with respect to a box plot? What is this called? This limit is called as, come on friends, this is called as lower limit. Yes, Q1, Q2, Q3. Lower limit, upper limit, right? Yes. Now, the question is, how are these Q1, Q2, Q3 getting calculated? How is lower limit, upper limit getting calculated? Everything we are going to understand. So far, we just understood by default we are visualizing a box plot. Am I right? But who is calculating Q1, Q2, Q3 for each and every column? For a for every column you are visualizing a box plot, and this box plot holds, it contains lower limit, upper limit, q1, q2, q3. But who is doing that? Python is doing that in the backend, but let us do it manually, right? So q2 is nothing but, it is also called as median. So you take any column and you calculate median of that column. What is the syntax to calculate median, friends? How can I calculate median of a column of a data? Okay. No, no, no. That's fine. Statistically, we have the formula, but the thing is, I'm asking with respect to Python. How can we do it in Python? What is the function that we use? Yes, median is nothing but the middle value of an ordered data set. Okay. Dot median is the function. Good. So the syntax is data frame or data dot column dot median. So this will return me the median value, which is nothing but the Q2 value. Okay, so in that way we will get the Q2 value. But how can we get Q1, Q3? Q1 is nothing but 25th percentile. Q3 is nothing but 75th percentile. So what I'm doing is I'm calculating Q1, Q2, Q3 using quantile function. Okay, so how am I doing it? Let us observe. See, what is the column that I'm actually working on? MPG city. So this is one of the column. So where I have outliers in the data set in this particular column. And for this column, I'm calculating Q1. Q1 is called as 25th percentile. So in order to calculate Q1, we use a function called quantile. So df of Akhil, what is this? For the first time I'm listening. Okay. Friends, how do you access data of a column which is present in the data frame? In general, we keep it as df dot column name. Am I right? Yes. But this is also equal, this is nothing but df of column. Both are same. The other way of representing the same thing. Okay, so when is this syntax used is when you want to, use the column for multiple times in the same line of code. This is preferred. This is not preferred. But for only once, in general, this is preferred. Right. But why are we using still if I'm using only for once? The thing is, in order to make you habituated, this is also the same representation of this friends. Okay, so df of the column name is mpg underscore city dot quantile. Quantile is the function which calculates these percentiles, and since it is 25th percentile, so the value that we have to pass is 0.25. Okay, it is 0.25. So this will give me Q1. Oh, is that much simple? Yes. The function that we are using is quantile, and once when you execute this, it gives me Q1 for MPG city. Okay, what if I want to calculate Q2? The same line of code, instead of 0.25, I have to pass 0.5. Since it is 50th percentile, so I have to pass 0.5. This will return me Q2. Okay, then in the same way, I want Q3, right? So in order to get Q3, 0.75 is what I have to pass. So this will return me Q3. Clear? So once if you get Q1, Q2, Q3, you are done with three components. But what is the IQR formula says? IQR is nothing but interquartile range, which is calculated by the different. I calculated Q1, then I calculated Q3, and finally I'm calculating IQR. So once if you get all these three, can't I calculate lower limit, upper limit? Yes, I can do it. How? Using the formulas. What is the formula for lower limit? Lower limit is nothing but it is given as Q1 minus 1.5 times of IQR. Q1 is here, IQR is here. So obviously we get lower limit. What is the formula for upper limit? Q3 plus 1.5 times of IQR. So Q3 is here, IQR is here. So this will return me lower limit and upper limit. So all of the components of a box plot are calculated manually. So this can be done for any column friends. If you have the data and if you want to calculate the components of a box plot, this is how you have to do it. Q1, Q2, Q3, then IQR, lower limit, upper limit. Once if these components are calculated, we can come up with the logic. Right. So Let us execute the code. I'm going to calculate Q1 and I'm storing it in Q1. What is the Q1 for MPG city? 17. What will be Q3? Let me execute. 21.25. Okay, so 17 and 21.25. The difference between 21.25 and 17 will be IQR. So nothing but 4.25 will be our IQR. Clear? When I substitute all these values in this formula, I get lower limit, and my lower limit says 10.625. In the same way, I'll also substitute these values in the formula for upper limit, and this gives me the value for upper limit as 27.625. Akhil, what is the use of calculating these, Akhil? Upper limit, lower limit. My friend, what is our aim? What are we going to do? We are going to treat outliers. So far we just understood visualizing this box plot which talks about outliers. But for the first time, we understood how the components of a box plot can be calculated manually. This is also fine. But the major thing that we have to focus is we can understand well with respect to these values. How? Okay, let me talk. What is your lower minds? MPG. What is your upper limit? Upper limit says 27.625. Okay. But assume there is a car which gives you a mileage as within the city, it is giving mileage as 5. MPG of a car within city is 5. Assume. So where does this 5 fall? Will it fall under this range? No. 5 is less than 10.625. It will be somewhere here. So this car will be an outlier. It will be an outlier. So we are going to we are going to treat these kind of outliers. Okay, assume there is a car like Maruti Suzuki, and it's giving around a mileage as 30. So 30 is again beyond. It is greater than 27.625. It will be somewhere here. So this will be an outlier. But what a car like say Shift Desire, okay, on an average it gives us 20, right? So it will be somewhere here. This is not an outlier, but these two are outliers. Might be this is say it as Rolls Royce, which just gives only 5.6 as mileage, not even 5.6. Okay, so probably I'm just assuming, but in short, this is how you have to interpret a box plot. Once if you understand the outliers, now you can treat them. Okay, so what is the technique that we are using? RRR. Out of RRR technique, we are learning the first R, recognize. We are identifying the outliers. So far, we just calculated them, the components. By using these values, I'll identify the outliers with a logic. So let us understand that logic, friends. It is clearly written here. See, let me get this down. Right. So df of within the data frame, within the data, this is what the condition says. The condition says if a value present in this column, if it is less than lower limit, or this pipe, this is called as vertical pipe. Okay, so vertical bar is representing a symbol called R. Okay, if values greater than upper limit, if the value is less than lower limit, or if the value is greater than upper limit, okay, identify such kind of values and store them in a separate object called outliers. Excuse me. Right. Let me execute this. Done. Right. Now I am printing all of them. See, actually I can't understand anything by printing it to the console. Can you open the variable explorer, that particular variable? Yes. Why did we get a data frame, Akhil? Because we are accessing from a 2D object and I have written the logic in order to get the entire data frame. So what is this data frame representing? This data frame is representing the information of outliers with respect to only one column friend. What is that one column? MPGCT. Okay. So what do you mean? That means, see, if the value is less than lower limit, so if it is less than 10, not even is equal to, okay, if the values are less than 10, or if the values are greater than 27, mark it as an outlier. So might be, all of these present in this data frame are outliers with respect to MPG city column. So what I'm doing, I identified these outliers. Now I'm trying to get the shape of, shape is an attribute, right? So data outliers is a data frame and shape of 0 will return me what? Only the rows. Shape should return us both rows and columns, but since I don't want to get columns, I want to get only rows. So it will be shape of 0, which will return me the number of rows, which is nothing but number of outliers. So this will return me 30. I am printing it to the console. Number of outliers in MPG city are 30. So I hope you understood, recognize, part of RRR technique. We are just identifying, but now comes remove technique. Remove technique says remove the outliers. Okay, so what I am doing is the same logic, but additionally there is a change. If the values present in that column, okay, if they are greater than or equals to lower limit, and if the values less than or equals to upper limit, only then you filter the data and store all these records in data underscore cleaned object. So this will contain the rows or the values of MPGCT which are beyond, which are present within the limits, right? So yes, I have executed and let me show it to you. Data clean, see 398. So if you observe in this data set, the maximum value with respect to MPGCT will be, see, it's 12, and let me get the from the region, it is 27, and it is 12 here. So whatever the values which are greater than or equals to lower limit, and whatever the values that are less than or equals to upper limit, only those will be part of this MPGCT. There is no outlier in this data. So how can you tell that again? What are the number of rows? 398. How many outliers did we observe? 30. 30 plus 398 is 428. So I got a data frame in which there is no outlier. There is no outlier. Okay, so this is called as remove technique, which is part of RRR. Remove will generally remove the outliers from the data frame. From the data, it is actually removing the outliers, right? But this is actually going to cause, data loss. And remove technique is not generally preferred because it is removing the data, right? So it is not generally preferred. And as the data is not having any kind of outliers, what am I doing? I'm taking the same data frame. Okay, I'm going to plot a box plot on this column. Let us check. Yes, I don't see any outliers. No more outliers. Remove. Okay, so remove technique is also clear. Then we have the third technique called replace, which is part of RRR. Recognize, remove, replace. So what are we doing as part of replace? The name itself it's telling, right? We are replacing the outlier with some value. What is that value? That value that we have here is, just give me a minute. Right. So what do you have? What are we going to do with respect to the replace? Under replace, what I'm doing is my logic says this is my logic. Mhm. Right. Let us understand the part and then we'll discuss. Right. So from NumPy module, I'm using a function called where, and this where function will identify, it takes each and every value present in this column and it checks whether the column is greater than upper limit. If it is greater than upper limit, then it proceeds. Okay, it keeps as is. What if it is less than, upper limit? If it is greater than upper limit, it replaces with upper limit. If the value is less than lower limit, it replaces with lower limit. What if the value is not satisfying these two conditions? You take the value as is and store all these values in a new column called mpg underscore replaced. Okay, and finally return this, convert this into a data frame, pd dot data frame. I'll repeat one more time. The logic is simple. The replace technique says that, whatever the outliers that we have, they are greater than upper limit, replace that outlier value with upper limit value. And if the value is less than lower limit, replace the value with lower limit. What if the value is not such, following these two conditions, then keep the value as it is. So this will generally return an array. That array object we are converting to data frame and storing in a new column which is mpgcity replaced. So let me execute that and show you the output. Done. So let me also show you df. See, mpgcity replaced, the new column that was created. So let us take some outliers. So see, 10 was replaced with 10.625. 10 was replaced with 10.625. Clear? So in this way, what I'm doing is whatever the outlier that I have is being converted to, you know, a normal value. It is converted to the upper limit or lower limit values. With respect to upper limit also, you see 60 was converted to 27.625, 59, 27.625. All of these will be converted till here. Okay, if the value is not following that condition, then obviously the value will be taken as is. Now I take these values of the new column that was created and generate or visualize a box plot, and this box plot also does not have any kind of outliers. Is that clear? Okay, so this marks the end of 3R technique. I'll quickly revise what did we discuss with respect to 3R technique. So 3R technique is a widely used technique compared to Winsorization not, but Winsorization is widely used. But in some cases, we also use 3R technique. 3R technique, R. Recognize, remove, rectify, are nothing but replace. Okay, so recognize, we just recognize the outliers. Okay, how many outliers we have is not we generally recognize. Then remove is where we remove the outliers. So this is going to cause data loss with respect to the data, and this is not generally preferred. And finally, the third one is replace, where we are going to replace the outlier value with the lower limit or upper limit value. When you perform these, the data will no more have outliers, the extreme values. Right. So now let us also discuss the widely used technique called Winsorization. This is called as Winsorization, the next technique. But Winsorization is completely easy because in the previous case, if you take 3R technique, in 3R technique, you have to come up with the logic. But this is a package. This is available as a module in Python. So the only thing is you have to go and read the documentation of Winsorizer, right? So this particular module is called as feature underscore engine. Yes, we can do it on each and every column of our data set, but I just performed it on only MPG as we are running out of time. I did not work on all the columns, but you are supposed to do it the same thing for all the columns in order to perform the same thing on all the columns. So Winsorization will be very fast. It's a very quick thing that you can do because it's a function. You need not write any kind of logic, so this will do everything for you. That's what. If you want to apply RRR technique, obviously, any one of the RRR technique, you have to, do it separately. But if you want to do it as a single or a group thing for all the columns of the data set, then you can directly apply Winsorization. This is not going to consume our time, but RRR technique, either it is replace, it consumes a lot of time because you have to calculate all the limits. For each and every column, you have to calculate these components, right? See, whatever we have calculated, these components are only for MPGCT. Okay, will upper limit or lower limit will be fixed for every column? No. Okay, I mean for all the columns, the upper limit and lower limit will not be same. It varies from each and every column. Column to column, this varies. So you have to calculate all these. For all the columns, you have to calculate Q1, Q3, then IQR, then lower limit, upper limit, which is time consuming. Once after calculating these components, you have to define the logic, right? So that is the reason we go and we go and use Winsorization. Winsorization is very easy because uh, it's available as a particular module in the Python, and by default you'll not have this particular module. If you have it, that's okay, friends. If you don't have this particular module, you have to install it. Okay, and the module name is feature engine, right? So from feature underscore engine dot outliers, within the module I have submodule, and within the submodule I'm importing only Winsorizer. This is the function. So I have it in my system. I imported it. Then I'm defining the Winsorization. So the Winsorizer function has four main parameters. One is the capping method, which method you are supposed to use. Then the tail parameter, then fold parameter, and finally variables, nothing but the data on which column you are going to work. Okay, even though if you don't pass these parameters, it executes. The reason is the default values will be assigned to these parameters, and the Winsorizer gets initialized, and it starts executing on the data, right? But let us understand what are these parameters. I request you guys to go through the documentation, friends. If you don't go through the documentation, you can't understand anything. Okay, so as it's not possible to understand each and every parameter present in Winsorizer within the session, I request all of you to go through the documentation. Capping method, I'm keeping it as IQR, interquartile range, and tail I'm defining it as both, so that it gives me the outliers at both the ends. Fold, I'm keeping it as 1.5. What is this 1.5 representing? It is representing 1.5 in the formula. What this is represented as fold. In order to calculate lower limit, upper limit, we are using a magnitude, right? This is called as fold. And finally, variables. Let me work on MPG city only. I'm defining the function and storing it to an object. So Windsor underscore IQR will be my function now. My function will be Windsor underscore IQR. So let me use my Windsor underscore IQR and work on the data. In order to, this is the function, right? So function dot fit underscore transform. This is an important function that we generally use with respect to data preprocessing. What exactly this fit underscore transform means? Fit underscore transform means the function gets fitted on the data, then it also transforms the results, right? So once if this is done, where are you storing it? The results of this you are storing in a new column of df with the name mpg city underscore iqr. See, done. So let me open df. The last column will be mpg city iqr. So this is the values that iqr, capping method iqr gave us. See how simple it is. Did we calculate limits? No. Did we calculate any components? No. Did we define any logic? No. The only thing that we have done is initializing the function with the parameters, okay, assigning this to a variable, an object, and this will be the function. And that function you will take and use fit underscore transform on the data, and that gives you the transformed results we are storing in a separate column. And by taking the values present in this new column, I am plotting a box plot, and it should not show me any kind of outliers. Job done. How simple it is. So majority of the folks in the real world, they use Winsorization for handling outliers. But again, it's up to you. That doesn't mean you should also use Winsorization. But in general, why it is widely used or why it is very popular? Because it's very easy, right? So it's not that much tough with respect to 3R technique. In 3R technique, we are supposed to define the logic separately. So this Winsorization, what I have done is I took different capping methods. So here it is IQR. Now I made it as Gaussian. So when the only difference is method, friends. Here interquartile range method is used, okay, to treat the outliers. In the same way, I'm using Gaussian method in the second phase. Rest of the code is same. See, everything is same. I'm initializing the function, then using this function, I'm using fit underscore transform function and I'm fitting on the data and I'm storing in a new column mpg city gov, where it is in the df. mpg city iqr, mpg city Gaussian. Are the results same? Yes. In each and every case, almost. In majority of the cases, it will be same. But in some cases, you'll find the deviation. Okay, let me show you the deviation also. Probably if you have anything, I'll show it to you. So unable to see anything over here. Ah, yes. See, here it is 10 and here it is 10.625. Okay, so a slight deviation is what you observe with respect to these different techniques. But what is the use of changing these techniques? See, whatever the method that you use, our ultimate aim is to remove the outliers, to handle the outliers. So, if you see here, is the outliers, did the outliers got treated? No, I still see the outliers. There are still outliers. So what does that means? Gaussian method is not fitting properly for MPGCT, but IQR method is actually fitting for MPGCT. Actually, what is the difference between IQR method, Gaussian method? Hmm. If that question rises in your mind, as I have told you, you have to go and read the documentation of the function Winsorizer. Because I just give you a hint. For IQR, we are using the formula as Q1 minus 1.5 times of IQR and Q3 plus 1.5 times of IQR. For Gaussian, the formulas gets changed. The formulas will be like mu plus or minus 3 sigma, mu plus 3 sigma, mu minus 3 sigma. So when the formulas change, obviously the values will change. When the values change, the method that you are using on a column may or may not fit properly. That's what it's clear. It is telling that Gaussian method is not fitting properly on MPGCT data set. Okay. So I think there is one more, right? In total, there are four different methods present in Winsorization, function. So the next method that we have is quantiles. Okay, so the fifth quantile will be treated as lower limit and the 95th quantile will be treated as upper limit by default. Okay, you can change it. So what I'm doing is the same code offline but changing the method, taking the same column mpgct and I'm experimenting whether this particular quantiles method fits on this column or not. So checking, I'm creating a new column mpgct percentiles within the data frame. Okay, so this is my new column. And if you see, are the results same? Almost same, right? So let me also see. There is a deviation with respect to the values. This column is representing the values from IQR method, and the next one is representing the values from Gaussian method, and the last one is representing the values from percentiles method. Nothing but quantiles. The values, if you see, they are 14, and here it is 10. Here is 10.625. So that's how the values get changed. Let me visualize the box plot on the transformer data. Is it changing or not? Let us see. Still I see outliers on the right hand side on the upper limit. So obviously quantiles method is also not fitting properly on MPGCT column. So in this way you have to do lot of experiments. and check which method is actually working well for your data. Okay, so what is tough in this, is something that you have to think is hands-on. And it's not, as we have discussed, it's not at all a movie. Okay, I sincerely suggest you to go and read the documentation of Winsorizer, which is available in this module. Okay, if you go and read the documentation of Winsorization, only then you'll understand properly the code. Whatever you have understood so far, it gets enhanced when you read the documentation, right? So go and read the documentation, pause the session, and redo the hands-on. You'll get the point clear, right? So just this is what I want to do for, or uh, do it for the day. It's done. Yet we have treated the outlier successfully, and the same process can be done for all the columns in which we have outliers. But Akhil, how can we give all the columns? Simple, friends. Here you pass list of columns. Here also. If not, define a list of columns. You pass that object here and the same way here. So in that way, you have to do n number of experiments. When you do all these experiments, you'll learn more, right? So I'll stop it here and I'll take up your questions. I don't want to drag it because this is an important topic for the day. I'll not teach the next one, right? So let us, do hands-on and read the documentation. You take any data set and do hands-on. So let me take up your technical questions. Any questions? Yes. 2 minutes, friends. We'll be posting the link. Do you have any kind of technical questions with respect to, uh, outlier treatment? Yeah, that's what I'm telling now, friend. Can we take more than one column, one variable? Yes, you can take all the variables at a time. Okay. Instead of taking one column, do one thing. Try it on all the columns. That is possible, but you are supposed to pass it as a list. When you will get to know that how can you take, or how to take more than one column, when you read the documentation. If you read the documentation of Winsorizer, you'll understand properly. Okay. Understood? Come on, friends. Yes. Any other questions? Fine. If no questions, we'll wind up the day here, and we'll continue with the rest of the topics in the next class. But before you leave, I request everyone to hit a, give a thumbs up, and then if you have any kind of technical questions, use the comment section. We'll reply hardly in minutes. Go to Play Store. How to download the app for certificate is the question. Go to Play Store. Okay, search for the name. Then you download the app. For time being, we'll tell you when to download the certificate. For time being, you have to attend these sessions. At the end of the sessions, we'll do some kind of projects. Yes, it will be on Monday. Yes, no class tomorrow. Then probably the timings will be same. We are not going to change the timings. I mean, it will be over from 7 to 8. Okay, so nothing else. But friends, utilize the time. do hands-on. Take a data set, do hands-on. If you don't work on hands-on, it will be like, just watching a movie. That's it. Yes. I'll keep it on the chat. Right. So give any questions. But before you leave, I want you guys to, uh, give a thumbs up. And if you feel these sessions are really valuable, share across multiple channels, friends. Yes. Ask your friends, your whomever it might be, ask them to utilize these sessions in a proper way. Soon we are going to, yes, we are going to launch a new program as well on the latest emerging tool called Power BI. Right. Thank you, friend. And I need your, valuable feedback. Hmm. Any kind of, even general questions you can ask me. That's fine. Even if you have any questions with respect to artificial intelligence, data science, machine learning, okay, and related questions are also accepted. If you belong to, say, your domain related questions, that's fine. Any questions? Sure, sure. We did not plan any session on DBMS. We'll see. Probably one will plan post Power BI. Okay, emerging technologies in the sense, what is the, technology that you want to learn, my friend? Which technology you want to learn? See, documentation. Every time I'm referring to the word documentation, right? So what does that mean? It means for every third-party function that we are using, okay. See, we are using read underscore CSV function from pandas. So this read underscore CSV function will have a documentation available in the official site of pandas. Okay, so that is the reason what I want you guys to do is go and read the documentation is what I'm telling you for understanding well, right? And I don't see majority of you are not following the instructions, but if you follow the instructions, if you read the documentation, your concepts will be clear, so that the way of using the parameters, the arguments will be in the right way. So documentations are available in the official sites of the packages, the modules. Open a browser, give them function name, and click on the enter button. You'll get the documentation link. Sir, could we have sessions on BioPython in future? Sure, we'll do it. AIML, okay. Friends, the current, or not only the current, even the future, the entire future is being, uh, it's going to depend on artificial intelligence. So what we are going to plan is we'll be planning n number of sessions that are beneficial for the future students, future. So such kind of sessions we are going to plan in future, especially that are related to AI and ML. And even we are also having a plan of coming up with new technologies. Okay, those sessions are also going to happen in future. But for updates, you have to subscribe to our channel. Only then will be updated with the sessions, the programs, and all. And with respect to the projects, we are going to start the projects probably in the next week with respect to this program. NLP project we are not going to do in this program, probably in the next program, not in this program. No, no comments on design and all. Using LLM Gen AI, we are also planning some sessions. Soon we'll launch those sessions. In order to get the updates, just subscribe to our channel. But sure, we'll be doing these programs for free. But in order to use it in an appropriate way, just subscribe to our channel to get the notifications. Right, I'll stop the day here. Thank you so much, friends, for joining today. Have a great day ahead. Bye. Signing off.